Hey everyone, and welcome. Today, we're diving into something called the data science methodology. Now, that might sound a little formal, but think of it as the ultimate blueprint, a guide that data pros use to solve all kinds of complex problems. It's our map for turning a mountain of raw data into some seriously powerful, real-world solutions.
So, you ever wonder how some apps can predict the price of a house almost perfectly? Or how you could even begin to guess what a student might score on their final exam? It honestly feels a bit like magic, right? Well, it's not. The secret is all about having a structured, methodical way to look at the data you've got.
And that's exactly what this methodology is. I like to think of it as a data detective's guidebook for cracking a tough case. It gives us a step-by-step process so we can make sure we don't miss any of those crucial clues hidden in the data. Our little investigation today is going to follow these key stages. We'll start with defining the problem, then we'll move on to wrangling the data. After that, we'll get into the exciting part, modeling and evaluation, and we'll wrap it all up with deployment and feedback. Okay, so our journey begins right here in the first stage, from problem to approach. You can think of this as the case briefing. Before a detective can solve a crime, they need to know what they're investigating. Same thing here. Everything, and I mean everything, starts with business understanding. What does the business actually need? What's the goal? Are we trying to boost sales, cut down on costs? Once we nail that down, then we can figure out our analytic approach. This is all about asking the right kind of question to get the answer we need. And asking the right question just means picking the right tool for the job. You see, if we're trying to predict a specific number, like a house price, that's a regression problem. If we're sorting things into buckets, like spam or not spam, that's classification. Or maybe we're just looking for natural groups with clustering, or trying to spot something weird with anomaly detection. Getting this right from the start is absolutely key. All right, so once we've defined our case, it's time for Module 2, gathering the evidence. This is where we roll up our sleeves and start collecting all the data, all the clues that we're going to need for our investigation. Now, our evidence can come from a couple of different places. Primary sources are clues we gather ourselves, like running a survey. It's raw, it's fresh, and it's usually super reliable. Then you've got secondary sources, which are clues that already exist, like data you find on a website or in some database. It's way faster to get, for sure, but we have to be really careful and make sure it's actually relevant to our case. So, once we have all our evidence, we can get a little clever with it. And that's where something called feature engineering comes in. It's basically the art of creating new, more powerful clues from the data you already have. Honestly, this step can be a total game changer for your model's accuracy. Let me give you an example. Let's say we're predicting house prices, and we have a column for year built. Well, a way more useful feature might be the age of the house, right? Or if you have price and area, you can easily create price per square foot. These new features just give our model so much more context to learn from. It's pretty cool. And hey, just a quick word of warning from one data detective to another. This whole stage, cleaning the data, transforming it, getting it ready, it's often the most time-consuming part of the entire process. No joke. It takes a lot of patience, but getting it right is absolutely essential. Okay, now we get to the really exciting part, Module 3, from modeling to evaluation. This is where the action really heats up. It's the cracking the case phase, where we take all that evidence we prepared and use it to build our AI model and start figuring things out. So you did it, you built your model, it's spitting out predictions like a champ. But here's the million-dollar question. How do you know if it's actually any good? How can you really trust that its predictions are correct? The answer is model validation. This is such a critical step. It's where we test our model on data it has never, ever seen before. It's like showing a detective a brand new piece of evidence to see if their theory still holds up. This is how we prove our model can handle the real world, not just the data we use to train it. There are a couple of common ways to do this. The simple train-test split is kind of like using 80% of your evidence to build your theory, and then using that last 20% to test it. But a more robust way is k-fold cross-validation. Here, you might split the data into, say, 5 chunks, and you test your model 5 different times, using a different chunk for testing each time. It's more work, but it gives you a much more reliable score. So, how do we actually score how well the model did? Well, we use different evaluation metrics depending on the problem. For this explainer, we're going to focus on regression models. With these, our metrics are all about measuring the error, or, just how far off our predictions are from the real thing.
Okay, let's break these down. First up, mean absolute error, or MAE. It's simple. It just gives us the average size of our mistakes. But what if one really big mistake is a huge problem for our case? Well, that's where mean squared error, or MSE, comes in handy. By squaring the error, it punishes those big misses way more. Now, to make that number a bit more intuitive, we can use RMSE, which just puts the error back into the original units, like dollars. And finally, you have R squared. This one tells you how much of the outcome your model can actually explain. A higher R squared is usually a pretty good sign.
And here's what that looks like in practice. The error is literally just the difference between the actual value and what your model predicted. To get that mean squared error we talked about, you just take that error for every single prediction, square it, and then find the average of all those squared values. That's really all there is to it.
And that brings us to our final stage, from deployment to feedback. We've cracked the case, and now it's time for the verdict, and to see what happens when our solution actually goes out into the wild. This is where our model goes from being a theory to a real tool.
So deployment is when the model officially goes live. It might become part of a website or an app or some tool a company uses. But the job's not done. The second part of this is feedback. We have to watch how it performs out there and collect all the data we can on its results. And that feedback can come from literally everywhere. We can get it from user surveys, comments on social media, support tickets, even from call center logs. All of this information is pure gold. It gives us the clues we need to keep making our model better and better over time. And this brings us to what might be the most important takeaway of all. This data science methodology, it isn't a straight line from start to finish. It's a continuous loop. The feedback we gather becomes new evidence, which lets us start the whole process over again, making our solutions smarter and more accurate with every single cycle. So there you have it, the Data Detective's blueprint for solving problems. It's an incredibly powerful framework for turning tough questions into real answers. Now that you've got the guide, the only question left is, what mystery are you going to solve first? Thanks so much for joining me.